History has deliberately forgotten half of its greatest scientists. This is not fiction, but the true story of women in science. For centuries, brilliant minds made discoveries that built our modern world, yet their names were erased, their work stolen, and their genius dismissed. You are about to meet 24 ingenious women who altered everything from medicine to astronomy, their stories recovered from the shadows. We will see how an 11th century doctor wrote the book on women's medicine, only to have male compilers plagiarize it for hundreds of years. You will learn how a master craftswoman engineered the sophisticated astrolabes that guided explorers, and how the collective knowledge of midwives formed the foundation of modern healthcare. This journey will give you a completely new understanding of how science truly progresses, revealing a hidden legacy of collaboration and resilience. How many revolutionary ideas were born in a convent's garden or an alewife's brewery? What does it mean for our future when we only hear half of the past story? The bustling port city of Salerno in the 11th century hummed with an intellectual energy rare for its time. Here, at the world's first medical school that openly welcomed women, we find our first ingenious healer, a physician named Trotula. She was not merely a practitioner but a celebrated professor and a prolific author, whose masterwork, known as The Diseases of Women, would echo through the halls of medicine for over 500 years. In an era where women's ailments were often dismissed as hysteria or divine punishment, Trotula presented a radical proposition. She argued that women's bodies were complex biological systems deserving of dedicated scientific study. Her book was a comprehensive guide, detailing everything from intricate surgical repairs to compassionate treatments for infertility. She boldly advocated for the use of opiates to ease the agonizing pain of childbirth, a concept of mercy that was centuries ahead of its time. Historians have meticulously traced how later male scribes and physicians systematically copied her work, stitching her chapters into their own books without ever mentioning her name. They erased her authorship, but they could not erase her ideas. Her texts are filled with detailed case studies that reveal a deeply empathetic healer, one who listened to her patients and grounded her practice in observation and evidence. It is a haunting question to consider how much sooner women's healthcare could have advanced if her pioneering voice had remained at the forefront. The compassionate science Trotula championed in southern Italy finds a powerful parallel in the work of another woman, half a world away. While Trotula advanced medicine within the halls of a school, another healer, Mercury, mastered it amidst the chaos of 14th century battlefield hospitals. As one of the celebrated women of Salerno, she was both a practicing surgeon and a formidable medical author. Her texts tackled the most urgent crises, from raging fevers and grievous wounds to the terrifying effects of poisonous bites. She did not just repeat ancient wisdom, she fused classical knowledge with the brutal realities of her own hands-on experience, creating a sophisticated guide for emergency care. Her writings reveal a clear understanding of what we now call triage, the critical practice of prioritizing the most urgent cases for swift intervention to save the most lives. It was a system born of necessity on the front lines of medieval conflict, yet, like so many of her peers, her individual voice was eventually silenced. Her influential manuscripts were copied and circulated widely, only to be absorbed piecemeal into larger, anonymous medical compendiums. Her name was scrubbed away, leaving her brilliant work as just another unattributed part of the medical canon. This erasure forces us to ask a difficult question. How many other advanced techniques for treating shock, managing pain, or closing wounds were lost forever when the names and contexts of women like Mercury were forgotten? This drive to understand the hidden mechanics of our world, whether in the human body or the cosmos, propelled another brilliant mind to look far beyond the battlefield, toward the intricate dance of the stars. High above the Rhine River, within the stone walls of her 12th century monastery, Hildegard of Bingen received visions of a universe alive with meaning. She translated these divine experiences into massive, encyclopedic books that mapped the entire natural world. Her works, known as Physica and Corsi et Curie, were revolutionary compendiums. Within their pages, she meticulously catalogued the healing properties of hundreds of plants, stones, and even animals, creating a practical guide for medieval medicine. But her genius went far beyond simple lists. Hildegard proposed a radical idea for her time, that physical health was inseparable from mental and spiritual wellness. She saw the human body as a microcosm of the universe itself, where imbalances in one's emotional or spiritual state could manifest as physical disease. This holistic view of medicine was centuries ahead of its time, and her creative genius extended beyond science, as musicologists now credit her with composing one of the largest surviving bodies of sacred music from the entire Middle Ages. While the Church celebrated her religious authority, this very framing became a double-edged sword for her scientific legacy. Her profound insights were often attributed solely to divine inspiration, quietly sidelining her own sharp empirical observations of the natural world. Hildegard's story is a powerful reminder that for medieval women, the path to scientific inquiry was often carved through sanctioned roles, like that of an abbess. How many other women used their positions within convents and religious houses to quietly study the stars, cultivate healing gardens, and document the secrets of nature? This very question leads us from the spiritual realm directly into the most practical of medieval sciences, the meticulous craft of turning observation into permanent record. Within the peaceful walls of Hohenberg Abbey, Abbess Herrad of Landsberg was building a different kind of garden, a garden of delights. This was no ordinary collection of flowers, but a breathtaking illuminated encyclopedia, a monumental work designed to educate the nuns in her care. Herrad did not merely copy old texts, she curated the entire universe of 12th century knowledge, from the intricate motions of planets to the complex philosophies of the ancient world. She translated dense, scholarly concepts into stunning visual art and clear language, creating a vibrant bridge between learning and faith. The Hortus Deliciarum was a masterpiece of synthesis, a testament to the immense intellectual labor involved in gathering, organizing, and explaining the world's knowledge for others. This role of the knowledge custodian, the great teacher and compiler, is a form of genius that history frequently overlooks in favor of the lone discoverer. Yet, without these curators, how would profound ideas ever find their audience? The tragic fate of her original manuscript, consumed by a fire in 1870, stands as a haunting symbol of all the vast repositories of female curated knowledge that have been lost to time. We are left to wonder what other illuminated gardens of science and philosophy have vanished, their splendor known only by faint echo. From this sacred work of mapping knowledge on the page, we turn to a woman who dedicated her life to mapping the pathways of the stars themselves. In 10th century Aleppo, a city shimmering with the intellectual fire of the Islamic Golden Age, a master craftswoman named Mariam Al-Ijley al-Astrolabe was perfecting the universe. Her medium was brass and her canvas was the sky itself, for she was a brilliant engineer of astrolabes. To call these devices mere maps is a profound understatement. They were the most sophisticated computational machines of their era, intricate brass models of the cosmos that could tell time, chart the positions of stars, and even determine the direction of Mecca for prayer. Mariam was not just assembling these instruments from her father Kutbul-Zeja's designs, she was actively innovating upon them, refining their gears and scales to achieve a level of precision that was previously unimaginable. Her reputation for excellence was so formidable that she secured a position crafting these devices for the court of the powerful ruler Saif al-Dawla, a testament to her unparalleled skill in a field overwhelmingly dominated by men. While the historical records that mention her are frustratingly brief, confirming her existence and profession but not the exact nature of her technical leaps, we can deduce her genius from the outcome. The creation of a more precise astrolabe was not an abstract achievement. It was the bedrock upon which countless other discoveries were built. Consider the astronomers who relied on her tools to make more accurate celestial observations, or the geographers who used them to draft better maps of the known world. The great voyages of exploration that would later connect continents depended fundamentally on the navigational accuracy that master craftswomen like Mariam made possible. Her story forces us to confront a difficult truth, that we celebrate the names of the explorers and astronomers, the men who used the tools, while the names of the women who engineered the very instruments that enabled their discoveries are lost to silence. This journey from the tangible craft of instrument making now leads us into a far more abstract and dangerous realm, the world of theoretical science, where another woman would make a breathtaking leap of logic, only to have her legacy face an even more direct and violent form of erasure. Dorothea Bocai occupied a chair of medicine at the University of Bologna for 4 decades, a fact that quietly shatters our image of the medieval university. She did not merely fill a position, she inherited her own father's prestigious post and then built upon it a legendary teaching career, drawing students from the farthest corners of Europe to her lectures. Imagine the dialogues that must have echoed through those halls, the complex medical disputations she led on anatomy and treatment. Her enduring presence in such a prominent role speaks louder than any single surviving text. It tells us that a woman's authority in medicine could be so widely recognized and respected that it overcame the rigid gender barriers of the age. While no specific books bear her name today, her intellectual contributions lived on through the hundreds of physicians she trained, their own practices undoubtedly shaped by her insights. Her legacy was woven directly into the fabric of European medical knowledge, even as the threads of her individual authorship were pulled loose over time. We are left to wonder what brilliant lectures were lost, what nuanced arguments she made in person that never made it to the page. Her story proves that prominence was possible, yet it also highlights a different kind of erasure, one where a woman's work becomes so foundational to an institution that her name simply fades from its walls. This transition from the public lecture hall leads us into a more secretive and mysterious space, the private workshop of an alchemist, where another woman pursued a radically different form of science. The alchemist's fire offered a different kind of illumination, one born not in a university hall but in a workshop filled with strange glassware and the scent of sulfur. In the smoky, intellectually charged atmosphere of Hellenistic Alexandria, a foundational genius known only as Maria the Jewess was building the very tools of science itself. Her inventions were not abstract theories but tangible, brilliant devices that would shape experimental practice for more than 1,000 years. Her most famous legacy is the bain-marie, the water bath that still carries her name. This was a revolutionary concept, a method for applying a gentle, consistent heat to delicate substances that would otherwise scorch or break down. Think of the precise temperatures required to melt an alloy or to infuse an herbal remedy, and you begin to understand the profound leap this represented. It moved alchemy from the realm of brute force into a more controlled, repeatable science. But her workshop held more marvels. She engineered the tribicos, a sophisticated three-armed alembic that vastly improved the ancient art of distillation, allowing for the careful separation of liquids. Then there was the mysterious karotakis, a sealed device for heating materials and collecting their vapors, a precursor to the reflux apparatuses used in modern chemistry labs. Her focus was on the transformation of matter, the physical manipulation of materials that forms the bedrock of all experimental chemistry. Later alchemical texts are filled with references to her wisdom, quoting cryptic axioms about the unity of matter, but her own identity has been completely absorbed by legend. We are left with a haunting paradox. The name Maria the Jewess echoes through history, attached to the most practical and enduring of tools, yet the woman herself is a ghost. How many other fundamental instruments were forged by women whose true stories are lost, leaving only their world-changing creations behind? This shift from the tangible tools of transformation leads us to a more abstract world of numbers and logic, where another woman would use her intellect to protect an entire city. The smoky workshops of alchemy gave way to the sunlit courtyards of 4th century Alexandria, where another kind of transformation was underway, the rigorous shaping of abstract thought. Here, the mathematician Pandrosian ran her own school, instructing students in the most advanced geometry of the age. We know she existed only through the faint, critical echo of a rival, the mathematician Pappus of Alexandria, who wrote a scathing critique of the methods used by one of her pupils. Yet in his very act of dismissal, he was forced to acknowledge her authority, referring to her explicitly as a teacher. This backhanded compliment, preserved by chance, is a fragile thread connecting us to a world where a woman's voice guided complex mathematical discourse. Her curriculum was not simple arithmetic. It involved the intricate principles of solid geometry and mathematical analysis, subjects that probe the very nature of space and form. Pappus' critique likely stemmed from a fierce professional rivalry, a clash of pedagogical methods that indirectly confirms the vigor and originality of the work happening under Pandrosian's guidance. Her school was clearly a recognized center of learning, its methods distinctive enough to provoke a published rebuttal from a leading intellectual. This single reference shatters the assumption that women were universally excluded from such high-level mathematics in the ancient world. It forces us to ask what brilliant proofs or novel solutions were debated within her classroom, ideas that, because they were transmitted orally or through since-lost notes, never entered the official, male-curated canon of mathematical history. The abstract lines and curves of geometry, however, were not the only domain where women applied precise calculation and systematic knowledge. This same intellectual rigor was being applied to one of the most fundamental and overlooked technologies of the medieval world, the complex, chemical-rich craft of textile production. The vast imperial gynaeceum of Constantinople was a humming fortress of industry, a place where silk thread spun not just fabric, but the very wealth of an empire. Within these women's workshops, legions of unnamed artisans held a state secret more valuable than gold, the complete mastery of sericulture. They were the anonymous engineers of the Byzantine silk monopoly, and their work was a symphony of intertwined sciences. To produce the shimmering cloth demanded by emperors and kings, these women had to be expert biologists, nurturing the delicate silkworms through their life cycles. They were practical chemists, pioneering complex formulas for vibrant, color-fast dyes extracted from minerals, plants, and insects. They were physicists, understanding the tensions and mechanics of their looms to weave patterns of breathtaking complexity. A single bolt of imperial silk was a culmination of countless experiments, a repository of chemical and technical knowledge passed down through generations of women. This collective genius created the economic engine that powered Byzantine diplomacy for centuries, with silk serving as the ultimate diplomatic gift. Yet the very system that elevated their craft ensured their erasure. The imperial monopoly treated their skills as a corporate secret, deliberately obscuring the individual innovators behind the legendary product. We can trace the influence of their chemical knowledge in the rich pigments that later illuminated manuscripts or the dyed woolens of other regions, but the names of the women who perfected these hues are lost. This tradition of collective, anonymous female innovation in practical chemistry did not end with the silks of Constantinople. It finds a powerful and surprising echo in the bustling, fragrant workshops of another group of medieval women, the brewers whose mastery of fermentation was every bit as scientific as it was culinary. The quiet hum of a monastic scriptorium could be as revolutionary as the roar of a battlefield. In 12th century Ruthenia, a princess-turned-abbess named Eupraxia of Polotsk, later known as Euphrosyne, understood this power completely. Her legacy was not a single discovery, but the creation of an entire ecosystem where science could survive and thrive. As a spiritual leader and a shrewd patron, she directed her royal resources and considerable influence toward the pursuit of healing. Historical records strongly suggest she either authored or personally commissioned medical texts that performed a vital act of synthesis, weaving together the practical folk wisdom of local herbalists with the sophisticated theories of Byzantine medicine. This was not mere compilation, it was intellectual fusion, creating new, more effective approaches to treatment. The monastery she founded became a beacon of literacy and learning, its scriptorium undoubtedly busy with the crucial work of copying not just prayer books, but also scientific and medical manuscripts. In an age before printing, this act of preservation was itself a profound scientific contribution. Without the safe havens created by patrons like Eupraxia, fragile scrolls of medical knowledge could have been lost to fire, decay, or simple neglect. Her story forces us to expand our definition of a scientist beyond the lone genius in a laboratory. The patron who funds the research, the abbess who protects the library, the ruler who builds the university, these figures are the unsung architects of progress. How many groundbreaking cures were discovered because a woman like Eupraxia ensured the right book survived long enough for the right mind to read it? This vital role of support stands in stark contrast to our next story, which returns us to the world of direct, hands-on invention where a woman's ingenuity literally reshaped the landscape. The beating heart of the most advanced computer in the medieval world was a web of brass so delicate it seemed spun from starlight. This was the Astrolabe's Reter, a rotating star map of breathtaking complexity. To create it, a craftsperson had to perform a kind of magic, translating the three-dimensional dome of the night sky onto a perfectly flat, two-dimensional disk. This required a deep understanding of stereographic projection, a mathematical technique that preserves the angles between celestial bodies even as it flattens their positions. Each delicate pointer on the Reter, shaped like a star or a leaf, had to be calculated and placed with absolute precision, its position verified against astronomical tables. While we celebrate master crafters like Mariam Al-Ijley for building the complete instrument, the evolution of the Reter itself was almost certainly a collaborative, cumulative effort. In the vibrant workshops of Baghdad and Cordoba, women skilled in both calculation and the engraver's art likely contributed to this painstaking process. They would have been the ones testing prototype designs, checking that the pointer for the star Sirius aligned perfectly with its true position on a clear night, and refining the intricate filigree that made each Reter a unique portrait of the cosmos. This was a fusion of high art and higher mathematics, a testament to collective genius. The astrolabe did not spring fully formed from a single mind, but was refined over generations by many hands, many of them now invisible to history. It forces us to look at every foundational technology and ask whose invisible fingerprints are on the gears, whose uncredited calculations guide the machine. This journey from the celestial to the terrestrial now leads us from the brass stars of the Herrad down to the green, living world of the medieval garden. The vibrant illuminations in Hildegard's manuscripts did not appear by divine command alone. Behind every painted plant and carefully inscribed line of text in works like the Physica stood a team of highly skilled nuns. These women were the anonymous collaborators who translated Hildegard's visionary knowledge into a tangible, permanent form. They were far more than mere copyists, their hands guided by a deep understanding of the natural world they depicted. To accurately illustrate the hundreds of herbs, trees, and animals described in Hildegard's writings, these artists needed a botanist's eye for detail. They had to capture the specific shape of a leaf, the precise arrangement of petals, and the unique texture of a root, because these visual clues were essential for correctly identifying a plant for its medicinal use. Their work required them to be keen observers, likely cross-referencing Hildegard's descriptions with the living specimens growing in their own monastery gardens and the surrounding forests. This was a collaborative model of science in action. Hildegard provided the theological framework and the core medical theories, but her sisters provided the empirical verification and the meticulous detail that made the text truly useful. They were active participants in the knowledge-making process, their silent observations ensuring the work's practical accuracy. How many subtle corrections did they make, noticing that a berry was depicted in the wrong season or a root structure was drawn inaccurately? Their contributions, though uncredited, were fundamental. This tradition of women quietly shaping science through careful observation in a garden leads us directly to their counterparts who are not just illustrating nature, but actively transforming it through chemistry. The earthy scent of malt and yeast was the smell of science in a medieval village. For centuries across Europe, the art of brewing was not just women's work, it was a sophisticated craft that belonged to them. These women, known as brewsters or alewives, were the undisputed masters of fermentation. Their brew houses were living laboratories where they conducted a delicate, daily experiment in biochemistry and microbiology. They learned to control temperature with an intuitive precision, keeping their vats warm enough to activate the yeast but not so hot as to kill it. They became expert judges of ingredient quality, knowing exactly how the purity of the water or the freshness of the barley would affect the final product. And they understood the behavior of that invisible, living organism, yeast, centuries before Louis Pasteur would ever give it a name. They knew that a portion of the frothy, active foam from one successful batch, what they called the goddess good, could be used to start the next, a practical application of culturing microorganisms. This was not merely about making ale. In a world where water was often unsafe to drink, their work ensured a nutritious, potable beverage that was a cornerstone of the diet. For many, it was also a vital source of financial independence, allowing them to support their families through a respected trade. Their practical, trial and error expertise in controlling living organisms was a genuine form of early biotechnology. Yet because it was women's work, because it emerged from the hearth and the home, it was systematically dismissed as mere household craft, its profound scientific principles ignored by the official records. How many foundational rules of microbiology were first discovered, applied, and perfected by these anonymous brewsters, their knowledge evaporating like steam from a cooling vat? This same hands-on mastery of the living body, applied on a much more intimate and terrifying scale, was the domain of our next healer, a woman who took the principles of the workshop and the brewery directly into the vulnerable human form. The sharp, clean scent of the barber surgeon's shop was a familiar one in any medieval town, a place where the line between a simple haircut and a life-saving operation was often blurred. Beyond the famous names of academic medicine, a whole class of women practitioners worked in this vital, hands-on trade. When a barber surgeon died, it was common for his widow to seamlessly inherit his practice, taking on his tools, his clients, and his hard-won reputation. Guild records from cities like London and Paris briefly note these women, licensing them to continue their husband's work. They were not merely caretakers of a business, they were master craftswomen of the human body. Their days were filled with the immediate demands of the sick and injured. They set broken bones with practiced skill, stitched deep lacerations, performed bloodlettings to balance the humors, and even undertook more perilous operations like amputations or removing bladder stones. This was knowledge written in calluses and scar tissue, an understanding of anatomy and physiology forged in the urgent, messy reality of the operating room, not the quiet isolation of a library. They knew which herbs dulled pain most effectively, how to pack a wound to prevent putrefaction, and the precise angle to use a scalpel to avoid a major artery. Yet, as the centuries turned, surgery began to transform from a craft into a formal profession. Universities established medical faculties, granting licenses and prestige, but these institutions systematically barred women from entry. The very gateways to professional legitimacy were closed. The practical, life-saving techniques these women had perfected through generations of direct experience were gradually absorbed into the growing body of surgical knowledge, but their names and their stories were stripped away. How many standard procedures for setting a compound fracture or safely lancing an abscess were first pioneered in a female barber surgeon's busy shop, only to be taught decades later in a university lecture hall as the discovery of a male professor? This systematic erasure of practical, embodied knowledge from the history of medicine finds a strange and profound parallel in the story of a woman who sought to understand not the body, but the entire cosmos, blending observation with a visionary spirit that defied easy categorization. The quiet rustle of parchment in 12th century Toledo was the sound of a continent waking up. In this vibrant Spanish city, where Muslim, Jewish, and Christian cultures converged, a monumental intellectual project was changing the world. Known as the Toledo School of Translators, this was the engine room of the European Renaissance, a place where the vast treasury of classical knowledge, preserved and expanded upon in Arabic for centuries, was being systematically translated into Latin. History books celebrate the men who led this effort, figures like Herrad of Cremona, but such a massive undertaking was never the work of a single genius. It ran on the labor of teams, a bustling ecosystem of scholars, scribes, and linguistic experts working in concert. And among these essential, uncredited collaborators were almost certainly Jewish and Mozarabic women. Fluent in the local Romance vernacular, often literate in Hebrew or Arabic from their household and community roles, and possessing the Latin needed for the final text, these women were the polyglot bridges across which entire libraries of science had to travel. Their task was far more profound than simple word substitution. Imagine the intellectual challenge of taking a dense Arabic treatise on astronomy, filled with precise terms for planetary motion, and finding a Latin equivalent that captured its exact mathematical meaning. Or consider a medical text describing a complex surgical procedure where a mistranslated term could lead to a fatal misunderstanding. These anonymous translators had to possess a deep, working knowledge of the subjects themselves to make such nuanced choices. They were not just moving words from one language to another, They were actively interpreting and reconstructing complex ideas for an entirely new audience. The very way that Aristotelian logic, Ptolemaic astronomy, and Avicennan medicine entered the European intellectual bloodstream was filtered through their discerning minds. The subtle choices they made in those scriptoriums, selecting one Latin word over another, forever shaped how the West came to understand everything from physics to human anatomy. We are left to wonder how many foundational concepts in modern science carry the invisible fingerprint of a woman's interpretive genius. This monumental act of cultural transmission, of making knowledge accessible, finds a powerful parallel in the work of a woman who was not translating texts, but translating the very fabric of nature into a new form of art and science. The courtroom in 14th century Paris was not a place of abstract debate, but a battleground for the very soul of healing. Here stood Jacoba Felicie, a respected and successful physician, charged with the crime of practicing medicine without the official license of the University of Paris. The detailed court records of her trial in 1322 offer a rare and damning window into the systematic campaign to dismantle women's medical authority. Patient after patient took the stand, providing sworn testimony of her remarkable cures. They spoke of illnesses that had baffled the university-trained male doctors, conditions that Jacoba had successfully diagnosed and treated. Her defense was as practical as it was profound. She argued that it was not only natural but morally right for women to treat women, especially for conditions that male physicians, constrained by propriety and a lack of shared experience, could never fully comprehend. This was not a denial of medical skill, but a powerful assertion that different kinds of knowledge, including the intimate understanding of a woman's body, were essential to true healing. Yet the court was unmoved. The verdict was a foregone conclusion, an institutional victory for the emerging professional class. Jacoba was formally forbidden from ever practicing again, her hands tied by a decree that valued a university seal over demonstrable healing power. Her case was not an isolated incident, but part of a calculated pattern. Across Europe, the rise of formal medical guilds and universities created new, legally enforced barriers, deliberately excluding women from the very institutions that were now claiming a monopoly on medical legitimacy. The knowledge that had flowed for centuries through the hands of women like Trotula and the Barber surgeons' widows was being systematically criminalized. We must ask ourselves as we read these dry legal transcripts, how many other brilliant healers like Jacoba were silenced by similar edicts? How many effective, compassionate cures were lost to communities because the only crime a woman could commit was to be competent without permission? This official suppression of a woman's direct observation of the human body finds a stark contrast in our next story, where another woman's quiet observation of the night sky would go completely unchallenged, simply because no one in power knew it was happening. A convent's bell marked not only the hours for prayer but the precise movements of the moon. Behind those stone walls, a different kind of devotion flourished, one that required a deep, practical understanding of the cosmos. The medieval nuns tasked with maintaining the liturgical calendar were, by necessity, astronomers. Their central challenge was the calculation of Easter, a date that depends on a complex interplay of solar and lunar cycles. This was no simple task of looking at a chart. It demanded a rigorous comprehension of the Metonic cycle, a 19-year period after which the phases of the moon repeat on the same dates. Their work involved intricate computations to align the lunar calendar with the solar year, a problem that had occupied the finest mathematical minds for centuries. While their names are almost universally lost, their collective labor was encoded into the calendars that structured the religious life of entire nations. Some monastic chronicles from this period contain tantalizing notes on celestial events, records of comets or eclipses, that were almost certainly logged by these women. In convents under learned abbesses, like those inspired by Hildegard of Bingen, this practical work could easily have blossomed into a more speculative curiosity about the nature of the stars and planets. This was science fully integrated into the fabric of daily life and spiritual authority, a domain where women not only had access to knowledge but were its essential custodians. How many quiet, nightly observations of a wandering planet, meticulously noted in a convent's ledger, contributed to the slow, collective understanding of our solar system. From the sacred timekeeping of the convent, we find the same practical ingenuity at work in the bustling, secular world of commerce. The rich, earthy scent of drying chamomile and the sharp tang of crushed minerals filled a different kind of workshop, the medieval apothecary shop. Often run by women, these establishments were the neighborhood's first line of defense against disease, a place where complex pharmacology met the daily needs of the sick. A female apothecary was far more than a simple shopkeeper. She was a master of three intertwined sciences. Her work demanded a botanist's deep knowledge of plants, knowing not just which herb to pick, but the exact time of year for its highest potency, which part of the root held the most medicine, and how to dry leaves without losing their vital essence. She was a practical chemist, expertly transforming raw materials into powerful medicines. She knew that soaking certain barks in alcohol would draw out their fever-reducing properties, creating a tincture. She understood that heating resins with oils would produce a soothing salve for wounds, and she possessed a crucial understanding of dosage, knowing the fine line between a healing remedy and a deadly poison. Her shop was a living laboratory, its shelves lined with jars containing everything from powdered hartshorn, a source of ammonia, to dried foxglove, the plant from which the heart medicine digitalis is derived. Guild records from cities like Frankfurt and London occasionally list the names of these women, granting them licenses to trade, but the true depth of their knowledge was rarely written down. Their most effective formulas were guarded trade secrets, passed from mother to daughter in whispered instructions, or hastily scribbled in personal notebooks that were used until they fell apart. These women operated at the critical intersection of learned tradition, perhaps from a text like Trotula's, and raw, empirical discovery. They were the ones who first noticed that a poultice made from willow bark eased aches and pains, centuries before science isolated the active compound, salicin, the precursor to aspirin. So much of our modern pharmacy has roots not in a sterile laboratory, but in the crowded, fragrant benches of these female apothecaries. Their legacy urges us to look at every commonplace medicine and ask, whose hands first ground these leaves, whose careful observation first noted this healing power. This earthly mastery over the properties of plants and minerals finds its ultimate reflection in a final, breathtaking attempt to master the cosmos itself, a story that returns us to the stars with one of history's most audacious female astronomers. The precise date of Easter rested on a foundation of numbers known as the Computus. For centuries, this was not a matter of looking at a pre-printed calendar, but an annual mathematical puzzle of breathtaking complexity. It demanded a synthesis of astronomy and arithmetic, reconciling the lunar month with the solar year to pinpoint a single, specific Sunday. And in monasteries across Europe, this formidable intellectual task was the domain of educated nuns who became known as Computrices. Their work was a meticulous application of a system refined over centuries, involving intricate cycles like the 19-year Metonic cycle and the 28-year solar cycle. A single miscalculation could throw the entire liturgical calendar of a region into disarray, disrupting the sacred rhythms of worship. This was not passive devotion but active, rigorous computation. These women had to track the golden number and the Sunday letter for any given year, performing calculations that required a firm grasp of modular arithmetic long before it was formally named. Their success created a unified Christian timekeeping system across a continent, a monumental achievement of distributed, long-term data processing managed almost entirely by women in cloistered communities. This sustained practice ensured that sophisticated mathematical skills were not just preserved but actively cultivated within female intellectual circles for generations. It was a quiet, constant exercise of the mind, a discipline that turned the observation of the heavens into a practical, earth-bound schedule. This same disciplined focus, applied not to the cycles of the moon but to the human body, defined the work of another group of practitioners whose knowledge was written in their hands. The quiet intensity of the birth chamber was a classroom that existed long before any medical school. Here, generation after generation of midwives built a monumental science of human life, their knowledge forged in the most urgent of circumstances. They were the undisputed masters of obstetrics, their expertise spanning the entire journey of pregnancy, labor, and recovery. This was not a simple collection of folk remedies, but a sophisticated system based on millennia of direct, hands-on observation. A master midwife could assess the position of a fetus through touch alone, recognizing the subtle signs of a breech presentation or a tangled cord long before modern imaging existed. They developed and refined techniques for managing protracted or difficult labors, using specific maneuvers to gently turn a baby or aid its descent. Their pharmacopoeia was vast and precise, a living library of herbal knowledge. They knew which steeped tea could strengthen contractions, which poultice could ease tearing, and which aromatics could soothe a mother's anxiety. This was a living science passed from experienced practitioner to apprentice through years of side-by-side work, a continuous chain of empirical learning. The tragedy is that this vast repository of data, this deep understanding of the female body, was almost entirely oral. It lived in the hands and memories of women, not on parchment. When male physicians began to formally document obstetrics in the early modern period, they did not collaborate with these experts. They systematically co-opted their hard-won knowledge while publicly discrediting the midwives themselves. The very women who had spent centuries perfecting the art of safe childbirth were branded as superstitious and unlearned, their authority stripped away by the new gatekeepers of institutional medicine. This represents one of history's most catastrophic losses of female-gathered scientific data. We are left to wonder how many effective, non-invasive techniques for managing preeclampsia or preventing postpartum hemorrhage were lost forever when a midwife took her unrecorded wisdom to the grave. How much sooner could maternal and infant mortality have been reduced if this deep, collective intelligence had been respected, studied, and integrated into the growing medical canon instead of being ruthlessly suppressed? This intimate science of life and matter, of the body's profound transformations, finds a powerful parallel in the work of a woman who sought to understand the fundamental transformations of the elements themselves. The scent of roses held more than memory, it held a precise temperature. In the still rooms of convents and the bustling workshops of Renaissance towns, women perfumers and distillers were conducting a silent chemical revolution. Their canvas was the petal, the root, and the resin, and their tools were the alembic and the retort, the very same glassware used by alchemists seeking to transform lead into gold. But their transformations were no less profound. Through a process called enfleurage, they would lay delicate flowers like jasmine on a layer of odorless fat, knowing the fat would act as a solvent, slowly absorbing the plant's volatile aromatic compounds over weeks. For hardier materials, they turned to distillation, boiling botanical matter with water and carefully capturing the condensed steam, which now carried the essence or hydrosol of the plant. This was not guesswork, it was a deep, practical understanding of chemistry. They knew that rose petals required a gentle, sustained heat to release their fragrance without scorching, while pine needles needed a more vigorous boil. They were masters of separation, of isolating a single, potent compound from a complex living mixture. Their creations filled churches with sanctifying incense and elite homes with perfumed gloves, but their most vital work was medicinal. They produced lavender waters to calm hysterias, rosemary spirits to cleanse wounds, and antiseptic solutions from thyme and sage. Their entire craft relied on a sophisticated form of qualitative analysis, one conducted with the nose and the eyes. They could assess the purity of an essence by its clarity and the complexity of its scent, judging the success of a reaction not by a number, but by a sensory truth. This intimate sensory relationship with matter was a genuine form of chemical knowledge, the foundation upon which the entire science of organic chemistry would later be built. Yet because their work was sold in small bottles and emerged from spaces associated with the home or the cloister, it was systematically dismissed as domestic craft, its chemical principles ignored by the emerging institutions of science. How many fundamental rules of solubility and volatility were first discovered in a perfumer's workshop, their origins lost in a cloud of fragrant steam? This mastery of transforming organic matter through fire and glass brings us back to the ultimate transformation, the power of the written word to preserve a legacy against all odds. The true power of a medical text lived in the hand that copied it. For centuries after Trotula of Salerno first wrote her words, the survival of her ideas depended entirely on the meticulous labor of anonymous women in monastic scriptoria. These scribes and illustrators, bent over parchment in the flickering candlelight, were the unsung engineers of medical transmission. Their task was far more profound than simple duplication. A scribe copying the Trotula manuscripts had to make constant, conscious choices. When she encountered a corrupted passage from a previous copy, perhaps a misspelled herb name or a confused dosage, she would use her own knowledge to correct it, ensuring the next physician would have accurate information. She might even add a brief note in the margin, a gloss from her own experience, clarifying a complex surgical procedure or suggesting a locally available substitute for a rare ingredient. These were not passive copyists, they were active editors and critical interpreters. Alongside them worked the illustrators whose brushes gave form to abstract knowledge. Drawing a detailed diagram of the female reproductive system or accurately depicting the shape of a specific surgical scalpel required more than artistic skill. It demanded a deep understanding of the subject matter. A misinterpreted drawing could lead to a fatal error in treatment. The clarity they brought to the page, the way they visualized a wound suture or the stages of a pregnancy, was a genuine intellectual contribution that shaped how generations of healers understood the human body. Modern paleographers can sometimes identify the distinct handwriting of a particular nun, tracing her work across multiple manuscripts, but her name is forever lost. We are left with a haunting legacy of collective, incremental refinement. How many of the subtle clarifications that made the Trotula text so enduring and practical for 500 years were the quiet contributions of these hidden women? Their work ensured that knowledge could withstand the decay of parchment and the chaos of history, a preservation of science that now leads us to consider those who did not just preserve nature, but actively sought to command it. A garden was a living library, its shelves stocked with leaves, roots, and flowers. In the walled plots of monasteries and the cottage patches of peasant homes, women served as the master librarians of this green science, a discipline we might call hortology. Their work was a sophisticated fusion of agronomy, soil chemistry, and practical genetics. They were not merely growing plants, they were actively engineering their ecosystem. A woman herbalist knew that planting beans near corn would fix nitrogen in the soil, naturally fertilizing the taller crop. She understood that spreading crushed eggshells could deter slugs, and that a spray made from boiled nettles would fortify plants against blight. This was empirical science of the highest order, a deep, localized knowledge of companion planting, pest management, and soil health passed from mother to daughter for generations. Their most profound innovation was in the realm of selective breeding. By saving seeds only from the hardiest kale plants or the most fragrant rose bushes, they were unconsciously manipulating genetics, slowly guiding the evolution of our food and medicine over centuries. The entire foundation of modern botany and pharmacology rests upon this bedrock of female-gathered data. Yet because this knowledge was applied daily, shared orally, and rooted in the domestic sphere, it was almost never written down in the systematic, Latin treatises of male scholars. We are left to wonder how many advanced techniques for crop rotation or natural pesticide recipes were lost when a gardener took her unrecorded wisdom to the grave. What revolutionary agricultural methods did they pioneer that we now simply take for granted as common sense? This final, collective portrait of countless unnamed cultivators brings us at last to our 24th and final innovator, a woman whose story brings our journey full circle from the soil back to the stars. The most forbidden space in medieval science was the anatomy theater, where the secrets of the human body were slowly, grimly unveiled. Into this world of cold flesh and academic solemnity steps our final figure, a woman whose story blurs the line between history and hopeful legend. Her name was Al-Ijley, and in the early 1400s she was said to be the prosector for the famed anatomist Mondino de Luisi at the University of Bologna. Her alleged role was as vital as it was gruesome. She prepared the cadavers for public dissection, meticulously cleaning and arranging the organs so her teacher could deliver his landmark lectures on human anatomy. The legend grows even more remarkable, crediting her with a breathtaking innovation. Frustrated by the delicate, near-invisible networks of veins and arteries, she supposedly devised a method to inject them with colored, hardening fluids. Imagine tracing the intricate pathways of the circulatory system for the very first time, not as a ghostly web, but as a vivid, three-dimensional map of blue and red flowing through the tissues. This technique would be a direct precursor to the anatomical injections that later revolutionized our understanding of the body. While the hard evidence for Alessandra's life is frustratingly scarce, leading many historians to debate her very existence, the persistent echo of her story is itself a powerful testament. Her legend endured because it filled a void in the cultural memory, preserving the idea that a woman not only belonged in that room, but could fundamentally advance its most cutting-edge practices. She represents the tantalizing possibility of female genius operating at the very heart of the anatomical revolution, a revolution that would ultimately claim the human body as a male scientific domain. How many other women, their names lost, worked in the shadows of the anatomy theater, their contributions fading into the stuff of folklore because their work was too radical, too threatening to be formally recorded. The story of Al-Ijley, whether fact or fable, brings us full circle. From Trotula's compassionate medicine to Alessandra's alleged anatomical art, we have traced a constellation of 24 brilliant minds. Their stories, recovered from footnotes, court records, and persistent legends, reveal a stunning pattern. These women were not rare exceptions, they were integral. They were physicians and surgeons, astronomers and engineers, chemists and mathematicians. They built the tools, translated the texts, funded the schools, and preserved the knowledge. They mastered the chemistry of dyes and the biology of fermentation, the mathematics of Easter and the physics of the astrolabe, their collective legacy forces a radical rethinking of how science progresses. It was never a straight line of lone male geniuses, but a sprawling, collaborative, and often hidden network. The true revolution was not just in the discoveries themselves, but in the resilience required to make them in a world determined to forget your name. Our future in science depends on us finally remembering them. This pattern of erasure was not a series of unfortunate accidents. It was a system. The very structures we built to record and validate knowledge were designed in a way that systematically filtered women out. When a male compiler stitched Trotula's chapters into his own book without credit, that was plagiarism. When the intricate chemical knowledge of the Byzantine silk weavers was recorded only as a corporate secret of the empire, that was absorption into anonymity. When the life-saving techniques of the Barber surgeon's widow were later taught in a university as a male professor's discovery, that was appropriation. And when Jacoba Fallacy was dragged into court and forbidden from healing, that was active suppression. The most insidious mechanism was the simple recategorization of their science as mere craft. The Brewster's mastery of microbiology was just housework. The astrolabe maker's precision engineering was just a trade. The midwife's vast empirical data on childbirth was just women's gossip. By defining true science as something that happened only in universities, in Latin texts, and through formal institutions, the gatekeepers rendered nearly all female contributions invisible by default. Our traditional history of science, focused on great men and landmark publications, is like a map that only shows the mountaintops. It misses the entire landscape of collaborative, incremental, and practical innovation that made those peaks possible. This distorted view has convinced us for centuries that scientific progress is a linear, male-dominated march, but the reality is so much richer and more human. It is a story of networks, of conversations in cloistered gardens, of recipes whispered in kitchens, and of tools refined in bustling workshops. Recognizing this pattern is not about casting blame on the past. It is about correcting a profound error in our collective memory. It forces a vital question upon us. If our understanding of the past is this incomplete, what brilliant minds are we overlooking today? Which fields of study are we currently dismissing as not real science, and whose voices are being silenced by the modern gatekeepers of knowledge? This journey through the lives of 24 ingenious women reveals a history of science far richer and more collaborative than we have ever been told. From the compassionate medicine of Trotula to the celestial engineering of Mariam Al-Ijley, from the intuitive biochemistry of the Brewsters to the life-saving obstetrics of the midwives, these women were not passive observers. They were active, essential architects of our scientific heritage. Their collective story is one of profound intellectual courage, a quiet resilience that pushed forward the boundaries of knowledge despite societal walls built to contain them. Reclaiming their legacies does more than just correct an old injustice in the history books. It fundamentally enriches our present by giving us a true picture of how knowledge is actually built. It is never the work of a single lone genius, but a sprawling, collaborative effort made by countless hands and minds, so many of which have been unjustly forgotten. Let their recovered stories inspire a new generation to question the narratives they are given, to look deeper into the footnotes, and to seek out the hidden figures in every field of study. The greatest tribute we can pay these pioneers is to ensure the search for the next lost name never truly ends, fueling our continuous quest for a complete and truly inclusive understanding of our shared past.